Okay, this is our lesson for section 9.2a. Essential standard. I can draw angles in standard position, find coterminal angles, convert angles between degrees and radians, and find arc lengths. And we're going to break this up over 2 lessons. An angle on the coordinate plane is in standard position if its vertex is at the origin and one of its rays is on the positive x-axis. Well, let's take a look at this. The ray on the positive x-axis is called the initial side of the angle. So here is the initial side. So this is the ray that's on the positive x-axis. And then we're going to take this ray right here and we're going to rotate it, which we have done. And we will, wherever it ends, that is called the terminal side. And this is the angle that creates. Okay, so there's theta. All right. Positive angles are angles that have their terminal side rotated counterclockwise. So if I rotate counterclockwise from standard position, starting at the positive x-axis, that is in the direction of positive. If I rotate from the positive x-axis in the negative direction or clockwise, that is considered negative. So it's kind of counterintuitive. It's actually opposite of what you would think. Clockwise might be something you would expect to be positive, but in actuality, it's the opposite. All right, this is another picture of that. So you can see here that I have started at the positive x-axis. I have rotated counterclockwise, so that is a positive 120 degrees to my terminal side of my angle. In this case, to the right, I have started at the positive x-axis. I have rotated clockwise. I have an angle that is between my starting point to my ending point, and it is a negative 140 degrees. So let's do some examples where we start to use this. We have been asked to draw an angle with the given measure, and we are to do it using standard position. So the first angle is a positive 210 degrees. So we will rotate. I have gone 90. I have gone 180. I can't go all the way to 270, but I'm approximately here. And there is my terminal end. And this angle will have a positive 210 degrees. I don't have to put the positive sign there, but there's my 210 degrees from my standard position, which starts at the positive x-axis. B, I have an angle that will be at negative 300 degrees, and it's again, instructions were in standard position. Standard position will have us start at the positive x-axis. I will start to rotate in the negative direction, which is clockwise. I have gone 90, I have gone 180, I have gone 270, and I need to go a little bit further. If I went a full circle, that would be 360, and so I'm in the first quadrant, and this will be, and I should show the direction that I turned here. That will be negative 300 degrees, starting from positive x-axis. All right, why don't you try one yourself? Welcome back. You have been asked to draw the angle of 100 degrees, starting from standard position. When I start from the positive x-axis, I go in the negative direction, which is clockwise. I have gone a negative 90. I'm not going to go quite to this would be negative 180, in other words. And so here is, we'll call that negative 100 degrees. Okay. All right. Now, angles are not limited to one rotation. We can actually go past 360, believe it or not. Angles can be rotated both counterclockwise and clockwise more than 360 degrees. So let's draw an angle of negative 400 degrees. So how do I do that? Well, I'm going to start at the positive x-axis. I am going to go in the negative direction. I have to go all the way around there. I have gone 360. If I go another 90, that would be 450. And so it's in between there. So I'm going to stop right about there and I'll call that negative 400 degrees. How about 720? How many multiples of 360 is 720? That is 2, and it's positive. So I'm going to start from my standard position, which is on the positive x-axis. I am going to rotate a positive 360 degrees, and I'm going to go another 360 degrees. And now I have gone a full 720 degrees in the positive direction. Your turn. Positive 540. Okay. So 540, if I take 540 and subtract 360, that gives me 180. So I've got to go a whole 360 plus another 180. So it kind of gives you a, you should look at it in multiples of 360. So it's positive. So I'm going to start counterclockwise. So I make one full rotation. I've gone 360. I've gone another 90. So that's 450. I need to go another 90, well, which would get me to 540, and I will end up right there. And that is a positive 540 degrees. So I went a full 360 plus 180. All right. 2 or more angles in standard position with the same terminal side are called coterminal angles. So we have to have the same terminal side. Coterminal angles can be found by adding or subtracting 360 degrees to angles measures. So you can have the same terminal end by just having multiples of 360. Coterminal angles are special, and you will learn about their properties later. They have to do with the values of sine and cosine. Okay, so let's take a look at what this means. I have an angle here that I have created by starting at the positive x-axis, and I have rotated in counterclockwise. So this is a positive angle, and here is my terminal end, and I can also go to that same terminal end if I started from the positive x-axis and have gone clockwise in the negative direction and end up at that same terminal end. Okay, both beta in that case and alpha are considered coterminal angles. Let's look at another example. I start again at the positive x-axis and go counterclockwise, so in the positive direction. And now I've stopped at this terminal end right here. And that would be some positive alpha right there. There's my positive alpha. And I could also then take and start again at my positive x-axis, go a full 360, and then add another, whatever that degree is, and have another angle called beta. And those again have a common terminal side, and therefore beta and alpha in that situation is considered kind of coterminal angles. Excuse me. Find an angle with a positive measure and an angle with a negative measure that are coterminal with the given angle. So let's see what we need to do here. So first, I am going to go ahead and draw my angle 130 degrees. And let's go ahead and let's see, start from my positive x-axis, and let's go to 130. So I got to go past 90, but not quite to 180. And so here is that positive 130 degrees drawn in standard position. Okay. Now we have been asked to draw a positive and negative measure that are coterminal. So here's what we're going to do. First, we're going to take that 130 and we're going to add 360 degrees. So we will get 490 degrees. So we are going to draw a positive 490 degrees. So I've got to go all the way around. There's 360. And if I go to here, guess what? That will be the same terminal end, and that is my positive 490 degrees. Now what I need to do is take my 130 and I'm going to subtract 360 from that. Okay, so I have negative 360 and I have the original value was 130. So if you take the difference of the two, and then you keep the sign of the larger number, you will get negative 230. And so I will do that in blue. And so starting from the positive x-axis and going in the negative direction, there's a negative 230, and I will end up right there with negative, I'm sorry, that was negative 180, and I had to go to negative 230, and that will be the same terminal end. So I have shown three angles that have the same terminal end. All right, let's do another one. I have negative 200. So I need to start from the positive x-axis. I have gone negative 90. I have gone negative 180. And I need to go a little bit further to get to negative 200. So maybe make it look something like that. And so there's my negative 200 degrees. And then I have to take my negative 200 and add to it 360. So we're going to do that. That's a 0. That will give me negative 3 minus 2 is 1. So if I add, I get a positive 160. And so we'll draw that one and it'll look something like this. That's 160. And then if I take my negative 200 and add a negative 360 to it, so we'll just add and keep the negative sign. That'll give me negative 560. And I'll do that one in blue. I have to go, there's minus 300, and there will be minus 560. They will all have the same terminal ends. They're multiples of 360. All right, why don't you try one yourself? Welcome back. I have a positive 80. I'm going to start from my positive x-axis. I'll be somewhere right about here. This is my positive 80. Now I'm going to take that 80. I'm going to add 360 to it. That'll give me a positive 440. And let's make that clear. That is 80 degrees. Now I'm going to go 440 in a positive direction. That'll be positive 440 degrees. Now I also need to take 80 degrees and subtract 360. So 360 and 80, subtract the difference, keep the sign of the larger number. So that'll give me a negative 280 degrees. I'm going to go a negative 280 degrees to get to the same terminal end. Okay. All right. One last topic for today. There is 360 degrees in a circle. Okay, I'm pretty sure you feel good about that. A radian. I'm not sure if this is the first time you've ever been introduced for this, but this is going to become quite important. A radian is the angular unit of measure, and it is defined such that 1 radian is the measurement of the angle that intercepts an arc that has a length equal to the radius of the circle. What does that mean, you say? So here is my angle theta. This is my radius of the circle. And this distance on that edge has some length, okay? And I am going to cut that arc length such that that S is going to equal the radius of the circle. Okay, I don't care what size circle it is. If the radius gets bigger, then S will be bigger. And every time you do that, this will have approximately, it's like 53 degrees or something to that effect. Nevertheless, that is defined in terms of radians as 1 radian. So we're going to cut this circle up. That is not actually drawn to scale, but we're going to cut this circle up into pieces, and we're going to define those that piece, which is that ratio, as 1 radian. Okay, so here's some important things to note. If I have gone around this circle all the way around, that's going to equal 360 degrees. Well, how many radians, since it's going to be exactly the same no matter what, if I go all the way around one circle, that is going to equal 2 pi radians. Okay, so one more thing to note. If I have gone half my distance, that is 180 degrees, and that will equal pi radians. So those are something you must know. You should know by the end of this unit, the fact that 1 radian is half a circle, 2 radians is pi radians is half a circle, and 2 pi radians is a full circle. So from this point on, if and by the way, radians is unitless. A lot of people you don't have to use rad, but sometimes you're going to notice that if an angular measure does not have a degree symbol, the angle is in radians. So what do we mean by that? So if we have 4 degrees, then we obviously know that the measure is in unit degree. However, if they tell you the angle is 4 and you leave the degree symbol off, then we have to assume that that is in units of radians. Radians is unitless, but if they don't have a degree symbol, then we have to assume it is in radians. Let me give you another example. You can actually have pi degrees for a measure of an angle, and it's in degrees. And if they give the angle to you in pi, then you must assume it is in radians. So this is very important. If you're meeting degrees, and make sure that degree symbol is there. All right, now we're going to have to get into conversion factors using these principles about radians and how many degrees equals a certain number of radians. So we have to learn how to convert from degrees to radians or radians to degrees. Now, I always have my physics students write on their board 360 degrees equals 2 pi radians, or 180 degrees equals pi radians. Okay, if you're converting degrees to radians, okay, so for example, 30 degrees, you would multiply it times the number of radians per degree. So you could use pi over 180 or 2 pi over 360, but notice that then the degrees will cancel and you will be left with units of radians. Okay. If you are going the other direction and you're going from radians to degrees, so for example, maybe we have an angle of 4 pi radians, I will multiply it by the number of radians on the denominator, and on top, what those radians is equivalent to in degrees. And my radians will cancel, and I'm left with degrees, okay? It's easy to identify what conversion factor you are to use by units. If you don't pay attention to your units and look at your units and which units cancel, then you will have trouble with this. And this was going to be important, not only in math, but your advanced science classes as well. So units are your friend. Okay, here we go. Again, 360 degrees equals 2 pi rads. So I want to convert either to degrees or radians based on what they gave us. So they gave me 30 degrees. I want to convert that to radians. So I'm going to multiply that by, well, degrees better be on the bottom because I need my degrees to cancel. And we can say 180 degrees is equal to pi radians. Now you can put your rad there if you want. You do not have to because radians is unitless, but it's just a placeholder. So You would multiply that out. You can leave the pi if you would like. 30 goes into 180 6 times, so that would be pi over 6. And that is an acceptable answer. Pi over 6 radians is also acceptable, but you do not have to write the radians. If it's not there, we assume it's radians, okay? B, I have no units there, so we're assuming that that is radians, and I need to get it in degrees. So I need to multiply it by my conversion factor, and that radians needs to be in the denominator because that is an invisible radians up top, okay? So I'm multiplying times, well, there's 180 degrees in pi radians. And so now my radians cancel. I have 180. Let's see, we can cancel our pi. We have, well, essentially that will simplify into a minus, there was a negative, 135 degrees. There's your answer. You can plug that into your calculator. Notice for C, it is no, there are no units, therefore it is in radian. So my radian, when I convert, needs to be on the bottom. So degrees needs to be on top. So 180 degrees equals 2 pi, or I'm sorry, pi radians. So my pi and my radians are going to cancel. And I know 6 goes into 183 times, and so, or 30 times, right? Yes. Yep. And then 30 times 5 is 150, and what unit is left is degrees. All right. 10, no units. What must be there? Radians. They're unitless. I know that's weird, but anyway, I need to convert that to degrees. So the degrees needs to be on top, and that pi, you can, if it makes you happy to put that radians there, you do not have to. Those radians cancel. I need to multiply 10 times 180, and you can leave the pi there, which in physics we don't, but in math evidently we do. 100 over pi, and that is in units of degrees. Okay, all right, try 2 yourself. Welcome back. So this is in radians, there's no degree symbol. So I'm going to multiply it times 180 degrees up top, my pi radians on the bottom. My pi is going to cancel, and then I will simplify that, and that will give me negative 225 degrees. 360 degrees. I need my degrees on the bottom. 180 degrees is equal to pi radians, and that will simplify into, well, let's see. Let's see, 30 goes into 180 6 times. 30 goes into 330 11 times. So that will give me 11 6 pi. Okay. All right. One last thing, and then we're done for today. This is considered a unit circle. It shows the degrees and radians relationship for some of our special angles that we have talked about in the past, 30, 60, 45, and 90. This is going to become very important in your pre-cal classes. In fact, eventually you have to memorize the unit circle. So you can see that at our 30 degrees, I have, it's equivalent to pi over 6. Notice that. I have a 45 degree angle, and that is pi over 4. I have a 90 degree angle, which is pi over 2, and that should be easy to figure out because 180 is pi. So half is 90, and that's pi over 2. And then the last one is 60, which is pi over 3. Okay, so there are some special angles. I believe you're going to get this unit circle for your test. I have to confirm that. but in pre-cal, you have to memorize this, and then actually there's quite a bit more to it than you have to memorize. So that is our, you might as well start memorizing it now. So, but you'll get it for this test. That's what I got. I'll see you in our next lesson.